Hi everyone. Let me know if I'm audible so that I can start the session. You can inform me by writing in the chat section if I'm audible. Okay, thanks. Well, so today, okay, let me share my screen and then we'll start with the session. So wait for a second. Well, yeah. So it's day 2 of week 1, and today we'll talk about arrays and binary search. So we'll start with very basic questions on array, and then I'll start with searching, like how we can do linear search. Then we'll talk about binary search, and we'll discuss few questions based on binary search, which are very common to the interviews. Right? So that's the agenda of today's session. Apart from that, I'll also talk about few of the points from the previous lecture. Okay, so I'll discuss that thing at the end, right? So as I said, I have also some announcement regarding the course and some other things. So I'll talk about. I'll make that announcement. Let's say, in the middle of the session. Okay, and then I'll discuss two questions based on array. Again, array means like we'll have a lot of questions on array. Like when we'll be solving questions on, let's say, dynamic programming or DP, uh, or let's say when we were solving problems on greedy and sorting. In all these topics, we'll be using arrays. So, but today we'll see very normal questions on array, like how we can solve. I would say a question based on array, which doesn't need any fancy algorithm, right? So that's the idea. And then we'll start searching. Like we'll talk about linear search, and then we'll solve binary search, and we'll solve some good questions based on binary search, which are very common to the interviews. Okay, so that's the idea. Okay, so announcements are like what should be the certificate criteria, then how you can get the class notes, and how you can practice problems. So these are the announcements I will make today. Yeah, apart from discussing the other things. Let's start solving first coding problem on array. I hope all of you know what is array, right? So the first problem is, don't worry, you will get all these things. You will get these notes. So don't worry about these codes and everything. So first question today, which I'll start with, is array rotation. Let me open this problem. Well, the problem is we will be given an array like this, and we have to write a code that can, that can rotate the array of size n by d elements, right? So like let's say if the d is 2, that means we need to rotate the array, uh, and the rotation will be left rotation. So we'll have to, like, okay, so after rotation, after two rotations, the array will be like this. So this first element, the one will go at the end, and then in the second iteration, in the second rotation, the two will go at the end, right? So okay, let me explain on the board so that you can understand it clearly. So what I was saying is, okay, so some of you, great. Uh, right. So what you let me. So someone suggested me to use this tool for writing code. That's why I'm using this tool, right? So yes, let's try. Yes, so let's say if you have array like this, 1, 2, 3, 4, 5, 6, and 7, right? So here the array size is 7, And let's say if d equal to 2, that means we have to rotate the array uh, by 2 elements, right? And it's left rotation. So basically, rotating this array one time means this one will go at the end. So it will be something like this: 2, 3, 4, 5, 6, 7, and then one will come here, right? So we have, so this is after first rotation. Then after second rotation, here these two, that means we have to rotate the array 2 times. So I mean, after second rotation, the array will be like this: 3, 4, 5, 6, 7, and 1, and then 2, right? So this is the meaning of rotation. So it's a left rotation by 2 elements. Okay. So we have to define a function. Let's say we have a function of y type in which we'll be given an array and we'll have the size of the array n and d. Then in this function, we'll have to rotate the array by d elements. So it's a very common interview question, and this question has been asked in companies like Amazon, Microsoft, and Adobe, Goldman Sachs, D Shop. So it's a very popular interview question. And again, we don't need any fancy algorithm to solve this problem. This problem can be solved, using very basic approach. Okay. So take some time and try to think about the logic, like how you can, solve this problem. I hope the question is clear. So the question was, we have to rotate the array d times, right? Like after first rotation, the array will be like this. So one will go there and we'll have something like this. After second rotation, the array will be like this, right? So d equal to 2 means we have to rotate the array 2 times. So that is the question. Yes, this is for fresher. Again, this question can be asked to a fresher, and if you are applying for SD2 roles, then also this question can be asked. So it's a very common interview question. Okay, great. So how we can rotate that, right? So one simple idea is, so let's talk about method 1, like how we can rotate the array easily. So the method 1 could be, we can use an extra array of size d. So let's say we have a temporary array of size d, right? And what I'll do is I'll copy the first 2 elements in that temporary array. So I'll copy the first d elements from the original array to this temporary array. So in the temporary array, we'll have these 2 elements, 1 and 2. Okay, because here d is 2, that's why we are taking the first 2 elements of the array. And then what I'll do is I'll shift all the elements. I shift all these. See, in the original array, we have something like this: 1, 2, 3, 4, 5, 6, 7. Right. So what I have done is I have copied these 2 elements in another array called temporary array, which is of size d. Okay, and then I'm shifting all the elements. I mean all n minus d elements. Right. So here these are the d elements and these are n minus d elements. So I'm simply shifting all these n minus d elements to the left side, right? So we'll have, so after shifting, the array will be something like this: 3, 4, 5, 6, 7, right? So basically we have shifted all these 4 elements, right? I mean, sorry, all these 5 elements. And at the end, we'll have like these 2 elements will be there as it is, right? Okay. So I hope you know like how we can write a code to shift these elements, right? So I'll show you the code as well, like how we can shift these elements by d in the left side, right? So after shifting, the array elements will be like this, right? And then what we can do is I can overwrite, right? I can change these values, I mean the last D values, with the help of this temporary array. So now the array will be like this: 3, 4, 5, 6, 7. And basically these two values, I mean these last D values will be changed by these D values in the temporary array. So it will be replaced by 1 and 2. So this is how I mean we can rotate the array by D elements. So this is the method one. This is not the most optimized way, but yeah, this is one way using which we can rotate an array by D elements. Let me know if it's clear. Okay, the question is, this is the question. The question is rotation of an array. So it's a very common interview question. And it has been asked in many companies, including Amazon, DSA, Adobe, Microsoft, and Goldman Sachs. So it's a very common interview question. So I just discussed about the approach one, like how we can rotate an array by D elements. Okay. So if you have joined late and you are not able to understand the question, then what you can do is you can simply, uh, you know, search on Google, like what is the question, right? Okay, so Aliva is very angry at me. She said that, okay, why you are not speaking English, Hindi? Okay, see, Aliva, the reason is that, like, so some of our audience can't understand Hindi, right? Like we have audience from, let's say, South India. Some of them are from US. So they will not be able to understand Hindi. That's why I'm using English, right? In fact, I'm more comfortable in Hindi, but uh, Hindi might not, like they will not be able to understand in Hindi. That's why I'm using English, right? Okay. So sorry for that if I'm not using Hindi, right? Well, okay. So I hope the method one is clear. Any doubt like how this method one is working? Okay. Well, so this, okay. Let me code the method one so that you can understand it easily. And in fact, I can simply copy that code from here. Okay, we don't have that code here, so it won't take much time to implement the method one, right? So see, I mean, let me repeat the steps. So what I was doing is I'm simply creating an array, an extra array of size D, right? And I'm simply copying the D elements, I mean the first D elements from the original array and storing in this temporary array. Okay. And then I'm shifting all the remaining elements. I would say all the n minus D elements. Like in this case, I'm shifting the remaining 5 elements of the array to the left side, right? So after shifting, the array will be like this. 3 will come here, then 4 will come here, then 5 will come here, then 6 will come here, right? And so on. Again, we are not shifting these two elements. I mean, okay, so at the end, these two elements will be there as it is. That's why we have a repetition of 6 and 7. And then I'll replace these two last elements, the two last, I would say, D last elements with these values stored in the temporary array. That's why we are using, I mean, that's why we have you know, repetition of 6 and 7, but we are replacing these values with the values stored in this temporary array, right? So this is the simple method one. Okay, let me code it. If you okay, so the simple code will be. I hope you can see my screen clearly. Let's say we have a function. Again, we should use good variable name. Let's say rotate array. We have again. I'll be writing pseudocode so that everyone can understand that code. Like if you code in C++ or in Java or in C or in C sharp or in JavaScript, still you'll be able to understand it. So it's not a very tough code to understand. Well, what I'll do is I'll create a temporary array of size d, and now I'm going to copy the first d elements from the original array to this temporary array. So I'll start from 0 to d I plus plus. What I'll do is I'll simply write temp of I is equal to array of I. Yes. So this is how we can, copy elements. Now what I'll do is now I have to shift all the elements. So I'll start from yeah, 0th index. I'll go to the dth index, and now I have to shift all the elements in the array. So array of I will be like at the 0th index we'll have array of I plus d element, right? Yeah, we'll have I plus d. Yes, yeah. So basically, uh, so let's say we have 1, 2, 3, 4, 5, 6. So at the first index, 3 will be there, right? That's why we are writing array of I is equal to array of I plus d. And we are doing this thing only for, so sorry, it should be for n minus d elements, right? It should be for there for 5 elements, right? Yeah. Hmm. Uh, okay. It is, yes, yeah. So that's correct. So basically we are shifting here, and then I have to replace the last d values with the temporary array. So what I'll do is I'll I'll start with uh, n minus d, and then I'll iterate till n. Basically, now I have to copy the last d elements from the temporary array. So I can write array of I is equal to array of I minus d. It should be okay. Or what I can do is I can, let's say I have one more variable called j is equal to 0, and I'll be incrementing j as well. So it will be, or I can simply write like this, j plus plus, right? Yeah. Basically, I'm starting from j equal to 0 to d. I'm copying all the elements to the original array. So this is the one way of, this is the method one to rotate the array. Let me know if you have any doubt in understanding the code or logic so that I can explain things. Yeah, I mean, you can write this thing in multiple ways, right? I'm simply writing like this, right? So it's totally up to you, like how you are implementing that thing. Chiraj is saying I'm new here. Here, I don't know anything. That's fine, Chirag. This course is for beginners as well, right? So if you are a beginner, if you don't know something, that is perfectly fine, right? You can still learn things. And again, the best outcome of this course is that you will come to know about the topics that you should know for the interviews, right? So these things will help you to uh, know, like, what are the things that you should work on to crack any coding interview, or how you can get a job in these top tech companies, right? So if you are a beginner, if you don't know anything about programming, or if you don't know anything about DSA and Algo, still this course will help you, right? Okay. Uh, repeat which thing? Repeat. I should repeat. Okay, so I hope the logic is clear, right? The logic was, we are doing three things, right? In the first step, we are simply creating an extra array of size d, and we are copying the first two elements, or I would say first d elements, from the original array to this temporary array, right? So in this temporary array, we'll have two elements, 1 and 2. Okay, and then we are shifting these n minus d elements to the left side. Okay, so after shifting, we'll have something like this. So basically, we have shifted all these five elements in the left, right? So it will be like this: 3, 4, 5, 6, 7, right? And these two last elements will be as it is there, right? And now we have to replace these two. I mean, I would say replace these d last values with the help of this temporary array. So we are using this temporary array to fail the last array, right? When fail the, I would say, replace the last d values of this main array. Okay. So we are doing three things: creating a temporary array and copying the first d elements in that array. Then, so we need three loops: one loop for this thing, one loop for shifting all the elements to the left, and the last loop should be to replace the last d elements from the temporary array to this main array or original array. So what we are doing is, here we are copying the first d elements from the original array to this temporary array, and then we are shifting n minus d elements. I would say for that example, the last five elements in the left side, right? So that we can have something like this: 3, 4, 5, 6. Now these five elements have been shifted to left side, right? And then in last, we have to replace the last d values, or I would say two values, because here d is 2, with the values stored in the, sorry, yeah, so basically we have something like this, right? We have something like this, right? We want to replace the two values with values stored in, because in the temporary array we have 1 and 2, right? So I want to replace these last two values with 1 and 2. That's why we have this thing. So in third loop, we are simply okay. So Kumari Sakshi is asking, is this course helpful for anyone? See, this course is helpful for anyone who wants to create the coding interviews of these top companies, right? So if you want to get a job in these companies, then you can go with this course. If you're already pro with DSA Algo, if you are really good at DSA Algo, if you can solve all the coding questions, then you don't need this course, right? Or I would say you don't need actually any course, right? If you're already good at that, so you don't need any course. But if you are a beginner or you are a medium level coder, you can't solve all the questions of DSA Algo, then you should join this course. That's the right, because this course is interview centric. This course will help you to learn things that will help you to crack the interviews, right? Well, see, in the last loop, we are, see, we have replaced these two values with temporary array, right? So what we are doing is, so we have one variable j. So array of I means, so we are starting from this index, right? We are starting from this index and going to till the nth index. So in this array, I mean in the last d values of array, we have to replace these two values with the values stored in this temporary array, so that we can have something like this. We can have something like this. The last two values will be replaced by 1. That's why we have this loop. Okay, you can write this loop in multiple ways, but yeah, this is the one way of writing the code. Okay, or another way could like you can write this loop like this as well. Like you can start from 0 to, let me, that might be helpful. Then you can write array of I plus uh, n minus p equal to imp of p. It will be, yeah. So yeah, so this is another way of writing the same code. I mean, this code will be share with you, right? It will be shared with you, so don't worry about. You can take some time, and again, this logic is there on this link. So I'll be sharing these class notes with you, so you can understand that code later as well. So what do you think? What about what do you think? What is the time complexity of this method, like method one? Anyone? Anyone? Yeah. Well, yeah. The time is O of n, right? It's that simple. Because here it will take O of d, O of n, and O of d. So O of d, O of n plus O of n is O of n only. So time is O of n. What about the space complexity? We are using an extra array of size d. That's why the space will be of d. I hope this thing is clear for everyone. So can we do something? Let's say extra space is not allowed. So can we do something so that we can do without extra space? Talk about method. Can we do something without using any extra space? Well, so in method 2, what we can do is, in method 2, what we can do, we can rotate the elements one by one d times. Like I'll have a loop and I'll rotate the array d times. Like first time, like in the first iteration, or I would say in the first rotation, the elements will be like this. We'll simply shift all the elements to the left side, right? So it will be 2, 3, 4, 5, 6, and 7. And we can store this variable in a variable. We can store this value, the first value, in a variable called, let's say, temp variable, and the last value will be replaced by this value 1. So this is how we can rotate the array by one element, and I'll repeat this process till d elements, right? So I rotate the array d times. So in the second iteration, or I would say in the second rotation, the elements will be like this: 3, 4, 5, 6, 7, 1, and then again this element will go to the last index, right? It will be 2. So here we are not using any extra array. What we are doing is we are simply using one variable called temp, and in this temp variable we are storing the value at the 0th index, the first value of the array, and then we are using that value in the last, and we are replacing, or I would say we are shifting all these values to the left. Okay. Yes, I'll talk about that, like how you can access my notes. So I'll be sharing my notes, right? Don't worry. Yeah, so the notes will be shared. Don't worry. Yeah. Well, so let me explain the method 2 with some code. So what I was saying is, let's say we have a method called rotate, and in this rotate method, I'll rotate the array. Okay, let's say we have the one main method which will rotate the array by d elements, right? So what I'll do is I'll rotate the array three times without using any extra space. I equal to I to d. What I'll do is I'll call a separate function rotate, which will rotate the array by one element, right? So this rotate function will rotate the array by one element. So I'll pass array. Let's see how we can implement this rotate function. So the idea of this rotate function is it should rotate the array by only one element. So we can have one variable called temp, and then we can simply shift all the elements uh, to the left, right? So I'll start from again 0 to, I will ignore the last element, so it will be a minus 1. Then array of I will be nothing but, basically I'm shifting all the elements in the left side by 1. That's why array of I will be array of I plus 1, right? Yes, this is how we can rotate the array by one element. And in the last, the array of n minus 1 will be what? It will be 10. That is the use of that last variable. So what we are doing is, let's say we have something like this, 1, 2, 5, right? So what we are doing is simply shifting all the elements by 1. This 2 will come here, this 3 will come here, right? So it will be something like this, 2, 3, 4, 5. And in the last, at the last index, we are overwriting that value with 1, with the first value. This is how this rotate function is rotating the array by one element. And we are calling this function d times that, and that's how we can get the array rotated d times. So here we are not using an extra space. Yeah. So I hope this second method is also clear. I'll talk about that, like from where you can get the notes. Okay, the reason that why we are not going to the last index, because see, we just want to shift the n minus 1 elements, right? That's why we are not going to the last index, because we just want to shift the n minus 1 elements only, not every element. Okay. Well, yes, this is another way of to solve that problem. So now if I talk about the, again, let's talk about the space first. So if I talk about the space complexity, we are not creating any new array, any extra array, right? We are simply using a variable temp. So the space complexity will be O of 1. And what about time? So see, this loop will take O of d, and this function, this rotate function will take how much time? This rotate function will take O of n time, right? Of n time. This step will take O of n time. So basically, we are calling a function which is taking n time. So that function is being called d times, right? So the total time complexity will be of n cross d, which is not better than the previous one. It's more than the previous one, right? So it's not better than method 1. But the good thing is that we are not using extra space. And again, in the interviews, it's not only about the base solution, it's also about like how you can solve a problem in the given constraint. Let's say if they are not allowing you to use an extra space, in this case, I mean, in that situation, this is a working solution without any extra space, right? In the interviews, it's not only about the base solution, it's also about the solution which can solve the problem in that given constraint, right? Like here the constraint is we can't use the extra space. Yeah. Vedant, it's not about printing. We have to rotate the array. It's not about printing. We have to change the array, right? So the array element should be changed. Not only about you know printing the array. Why space not n plus one? See, we are not using any extra space, right? So this array is already given. So we have already an array. In this function, we are not creating a new array. Okay. So that array was already there. In this function, we are not creating a new array. That's why it's not O of n. Yeah, so Pratham is asking which approach is better. Well, if you talk about the time complexity, this the method one is better. But if I talk about the space, method two is better, right? So it's nothing like a best, nothing is like a better solution. It depends on the situation. We have one more method, method three, which is best, and which is better than method one and method two. And that approach is, well, we have something called method three. See, it's a very common interview question. So in the interviews, they expect the best solution. If you want to crack the interview, uh, I mean, you will have to reach to the most efficient solution, and to reach to that solution, you should know about all these things, like how to solve a problem, right? See, in array, it's always called by reference, right? So array is nothing but a, like in C++, it's called by reference, right? So the change in the array will be reflected everywhere. So array is called by value. Sorry, called by reference always. Uh, hmm. Take example. Okay. Let's talk about the method three, right? So what we can do in method three is we can reverse the first d elements, right? And then we can again reverse the n minus d elements, right? And then we can reverse the whole array, I mean the all the elements. So we can do three things. In the first step, we can reverse the array. I mean only the first d elements of the array. Let's say we have something like this: 1, 2, 3, 4, 5, 6, 7. So reversing the first d elements is nothing but simply we are reversing these two elements. That will be 2 and 1, and rest of them will be same. So after step 1, we'll have something like this, right? Then we have to reverse n minus d elements. I mean, so we have to reverse the first d elements here, when the starting d elements, and then we have to reverse the last n minus d elements. I mean this portion. Okay. So now we need to reverse this portion. This portion. So after step 2, what will happen is we'll have something like this. I mean the first. I mean the first portion will be will not be affected. This will be reversed. So we'll have something like this. We'll have 7, 6, 5, 4, 3. And then we can reverse the whole array. So after step 3rd, what will happen is we can reverse the whole array. So it will be something like this. 3, 4, 5, 6, 7, 1 and 2, right? And this is what we were looking for. So yeah, so using these 3 steps, I mean reversing the first d elements and then reversing the last n minus d elements and then reversing the whole array will help us to rotate the array by d elements, right? Okay. And the best thing is that we are not using any extra space, and also the time complexity will be O of n only. So this is the best solution, right? Yeah. So let me repeat the steps. The steps are uh, we are reversing the first d elements. So it will become like this 2 and 1. Then we are reversing the last n minus d elements 3, 4, 5, 6, 7, right? And then we are reversing the whole array, right? So after reversing this thing, it will have something like this 3, 4, 5, 6, 7, 1, 2, right? So in these three steps, we can rotate the array by d. So let me uh, so can you code for this thing? Yeah, so it's O of n, right? See, the cost of this operation is O of d. The cost of this operation is O of n, or it's O of n minus d actually, or let's say it's O of n only. And the cost of this is O of n, right? So it's O of d plus O of n plus O of n. So it's overall O of n only. So the time complexity is O of n only. And we are not using any extra space. So the space complexity is O of 1 itself. Yeah. The one question is how we can get this type of thinking by solving a lot of problems, right? So that's the only way to develop critical thinking or thinking ability or problem solving skill. You will have to solve a lot of problems, right? Okay. So 2n means n, right? 2n is n only. And I hope you know how to reverse an array. I can simply copy that code from, yeah, so let me, okay. Let me simply copy the code so that we can save some time, right? Of course, I can. Again, on the link that I have shared, you can find everything, the detail and everything. So you can ignore this thing. We are doing three things. We are reversing the first d elements, and we are reversing the last n minus d elements, and then we are reversing the whole array, right? So we have a function called reverse array, in which we have to provide the start and end index, and this function will reverse the array, right? So I hope you know how to reverse an array. Someone is asking best website to these kind of questions. Amresh, the best website is GeeksforGeeks, right? So you can go to GeeksforGeeks and you can simply solve a lot of questions based on array. So if I can quickly show you, like, well, so you can simply go to GeeksforGeeks. You can go in the DS section. You can go to the arrays, and here you can see more than 200 questions based on array. I'm talking about. So I just discussed this question program for error rotation, right? So here you can see a lot of questions are there based on array only. So you can practice such questions from GeeksforGeeks, right? So the base website for DSA and Algo at least. Okay. And all these things are free. Again, in this course, you will learn about all these things, like how to represent things in the interviews, what are the resources to learn something, how to practice questions, right? So that's why if you are preparing for the interviews, whether you are preparing for internships or full time, or you are a working professional and you want to switch from another company, right? And switch from one company to some other company, still you can join this course, right? Because when I was switching from Paytm to Adobe, I mean, I was asked a lot of questions on DSA and Algo. So you need to be good at coding to crack any interview, right? Any tech interview. Okay. Well, so this is a question which is based on array, right? So there are many more questions, and we will talk about those questions later. Yeah. So any doubt in this question? Anything that you want to ask? Okay, let me do some announcement so that, yeah. So okay. The first announcement is like what is the certificate criteria, right? So our team will mail you that. So okay, so there is a cutoff mark that you will have to cross to get the certificate, right? And that mark has been decided. So it's I would say it is 950 marks in the practice section, and in the contest section it's 550, right? So those details will be shared with you on email. So if you have registered in that course, you can get that detail by tomorrow. So our team will send you that criteria for certificate on your email, right? So we have decided a mark. So you will have to, again, when you will solve a problem, practice problem, then you will have some marks, right? Like, let me show you like how you can get that. Okay. So I hope all of you have access to this track, okay, where you can, see the topics on array, like what is array, then some questions based on array, right? So let's say we are going to topic array. 95 is bit. No, I don't think so. Right. See, I mean, if you don't solve those questions, then I mean, I don't think this course will help you, right? And neither that certificate will help you. So uh, again, I mean, certificate is one thing that will motivate you to solve some questions. So that's the idea of keeping that threshold high, because that certificate will not help you to get a job, right? Your knowledge will help you to get a job. So let's say if you have that certificate in free, then I don't think that certificate will have any value. So that's why we have that threshold value, so that you can get motivation to solve more and more questions. So that's the idea. Okay. And this is how you can learn a lot of things. Because I mean, see, no certificate will help you to get a job, right? So no, I know my friends who are from ITs, still they are not able to crack some companies, because I mean that certificate of BTech, that BTech degree, even that BTech degree of 4 years will not help you to get a job. So I mean, you can't expect that, okay, any certificate which is a training certificate or any course certificate will help you to get a job, right? Okay. Again, these certificates might help you to get the interview calls, but in the interviews you'll have to solve those questions, right? So if you have not practiced enough, and if you have not solved much question, then I don't think you will be able to crack the interview. That's why we have that threshold value, right? Okay. So like on theory section, you will see like, okay, you have theory about array, like how to insert things in array, how you can delete from array, then what is the time complexity of insertion or deletion in an array, right? And then you can see some problems based on array. Like the one question was, which I just discussed. It has been asked in Amazon and Mac. Actually, it has been asked in many more companies, but yeah. So this was the question. So when you will submit this question, you will get some marks, right? Okay. And so again, I'm not sure about the exact marks. I guess it was 950 or something. So I mean, you will get that written on the mail, right? Okay. So our team will shoot you mail, and on that mail you can find the details. But the idea is you will have to solve some questions, right? Okay. So this is a practice question. Apart from these practice questions, you have one thing called uh, contest, right? So contest is uh, again, if you are preparing for the interviews, your first round might be conducted on HackerRank or similar platform, right? And in that round, you can expect some coding questions which you will have to solve in 1 hour or 1.5 hours, right? So the idea of this contest is to help you uh, in assess yourself, like how prepared you are, and are you able to solve a question in that given time constraint. Because again, in the interviews, I mean, in the first coding round or machine coding round or online coding round, or in fact in the face-to-face rounds, time is important, right? You will have to solve the questions within that time limit, right? So that's why the concept of contest is there. You'll have to solve some questions in that given time constraint. Like for the contest one, the time is 1 hour and 15 minutes. Similarly, for each topic on, I mean, in each week you will have one contest, right? Okay, so that's the idea. Okay, I mean the cutoff mark is too high, right? So okay, so okay, I mean, so if you get the certificate in free, right? So do you think that that certificate will help you? The purpose of this course is to, help you learn all these things, right? If you're not learning all these things, then I don't think you'll be able to crack those interviews, right? So you should practice a lot of questions, right? Like I have solved, I mean, more than 1,000 questions, including questions from Geeks for Geeks and other websites like Spause, HackerRank, CodeChef. There are many other websites that I have solved questions on. So I mean, you should at least solve, I would say, questions which are there. So on these tracks, you will have more than, I would say, 300 questions, which should be sufficient for your interviews, right? So this is the minimum set of questions you need to practice to get a job, right? There are many coders which, so I mean, they solve a lot of more questions, but yeah, this is the minimum set of questions that you must do to get a job, right? So there's no shortcut. I mean, to get a job, right? Uh, I don't think there's a date. There's a timeline. And again, if you have any, yeah, here we go. So here you can see the cutoff mark. So for, yeah, so for the track it is 550, and for the contest it is 900, right? So here you can see in the notification board the criteria for certificate is, in the track you should have at least 550 marks, and in the contest you have to achieve at least 900 marks, right? So to get the certificate. And I think getting 550 is not that much. So if you are able to solve 50% of questions, then you can easily get the certificate, right? So that's the idea. Yeah. Apart from that, if you have any other doubt, then what you can do is you can simply drop a mail to us, right? Like you can go to course page and there's a email ID called Geeks Classes. So you can simply mail us and our team will help you with your query, right? Another thing was class notes, right? So I have shared my class notes on a Google Doc, and the link of that Google Doc will be shared with you on your email ID, on your registered email ID. And on the same doc, I'll be sharing everything, right? Like here you can see on the same file, I'm writing the same code. So all these things will be shared on that Google Doc, and you will have the read-only access of that Google Doc, right? So where you can access your class notes. So in that note, you will have the link of the problem, and you will have the code like this. You can also expect, these diagrams, right? Like, so I can also uh, upload these, the these drawings on my board, right? So you can expect this thing as well. Yeah. So all these things will be shared on your email ID. Okay, I have said that thing multiple times. So week 3 will be visible after week 2, right? So have patience. Well, uh, I think I have talked about this thing, like how to practice problems. So you can simply go to any topic, like you can go to array and you can go to the problem section. Let me show you once again. Like you can go to uh, any topic, like let's say arrays, and then you can go to the problems, and here you can solve problems, right? Okay. and after submitting that problem you will get some marks, right? Okay, I mean you can try any. So all these problems are there, right? On every topic you can find a lot of problems and you will have to simply solve those problems to. Again, the idea is this is how you will learn coding, this is how you will learn problem solving, right? Well, yeah, so I think I'm done with the these things. There's one more thing that I want to talk about. So we have one thing which is going on, which is Black Friday sale, right? So you can find the link of this article in the video description, right? We have a Black Friday sale in which you can, you know, get our courses with a very good discount, right? Like you can choose our online courses. You can choose our live courses, and in each course you can get some discount, right? So there are a lot of things. The one thing is like for like for one day you can expect super sale on all the courses, right? Apart from that, there will be some flash sales on some selected courses, and those flash sales will be for let's say 20 minutes or 15 minutes, right? So all these things are written there, and you can simply explore this article link to know more about this flash sale and other things, right? And also we are launching some new courses. So yeah, so if you want to join any paid course, then you can explore this page, right? Okay, let's back to new problems, right? Okay, again, I don't have much time, so let's start with searching, right? Searching means, let's say we have a function called search. Let's say we are given an array, and we have to simply, and let's say we are given an integer x, and if let's say in the array we have elements like 2, 4, 8, 12, 15, 10, and right. Let's say x is 15, right? Yeah. So when search means this function will simply search this element x in the array. If this element is in the array, then this function should return true, that okay, this element is there in the array, or we can return index of the that element, right? Like in this example, this function should return 3, right? Because 3 is the index of 15 in the array. Let's say if x is I would say, let's say if x is 6, right? Then the output should be -1, right? So this is output is 3, and here the output should be -1 because we don't have any element like 6 in there. That's why we're returning -1. -1 means there's no element equal to x in the array. This is the meaning of searching. So we have to define a function that can search an element in the array. So how we can do that? How we can search an element in the array? Sorry, the index is 4. Sorry, the index is 4. Thank you. Nice. Yeah. So there is one algorithm called linear search, right? The simple idea is we can iterate in the array. I can iterate in the array, and I'll compare this x with all the elements one by one, right? So linear search means, I mean, it's quite simple, right? Linear search means if you have something like this 2, 3, 4, 9, 7, 10, 5, and so on, and let's say x is 7, right? So what we can do is I'm simply iterating from the beginning, and I'm comparing all the elements of the array with x, and when I will get that element I can return the index of that element, right? Otherwise, let's say if x is 12, in that case I will not get any index, right? I will not, because there is no element equal to 12. So I mean, we'll be done with the searching in the whole array and we'll not get any match, right? So in that case we can return -1 because we don't have any element equal to 12, right? So that is the idea of linear search. We are simply searching linearly. Okay. So the code of linear search is quite simple. We can simply write a loop like this: I equal to 0, I less than n. If array of I is equal to x, then return the index I, right? Otherwise, return -1 if you're not getting any element equal to. So that's the code of linear search. Okay, Anup is asking where is the invitation code, right? So you can simply shoot email, right? You can simply shoot email to us. You will have everything. Okay. So I hope this code is quite simple, right? So the cost of, I mean, the time complexity of this code is O of n, and this algorithm of searching is called linear search because we are searching linearly. And the space is O of 1 because we are not using any extra array or something. Linear time complexity O of n. Okay. Searching can be improved. Like if you're using hashing, I'll talk about hashing later. So if you're using hashing, then searching can be improved. Apart from that, if we have sorted data, right? Let's say if you have sorted data, sorted, let's say array. In that case, we can search things efficiently because we have something called binary search. Binary search is an algorithm which will help us to search in a sorted array, and it is better than often it is login, right? It will take login time. Yeah, so the drawback is it works for only binary searching. So that's correct. Okay. Yeah. So let's see how binary search works. Let me explain the binary search, like how it works, and then we'll solve some questions based on binary search. Okay. So let's say we have something like this: 2, then 5, then 6, then 10, then 15, and then let's say 20. And let's say I'm searching for 15, right? Okay, so binary search is very, I would say, simple searching technique. So the idea is, so let's say you are given a book, right? Let's say you are given a book, and let's say book has total 300 pages, right? Book has total 300 pages, and let's say if you want to go to page number 100, right? So how you can go to that page? How you can open that page number 100? So the one way could be you can start from page number 1 and you can, you know, uh, go to that page number 100 one by one, right? Like you can turn one page, then another page, and so on, right? So that's the one way of reaching to the page. I mean, the page number with, I mean, the hundredth, the page number 100, right? That's the one way. So that is similar to linear search, right? Because we are iterating, we are going through each and every page, right, one by one. So that is the one thing. So can we do something better? Like, can we do something so that we can uh, go to that page easily? Yeah, so we can do one thing. Like, we can simply open that book from middle, right? So let's say if you're opening that book, again in the book you can't exactly find the middle, but you can find the approx middle. Like, let's say you open the middle of the book and you get, let's say, page number 130, right? Because you can't exactly go to the middle page, right? I mean, it's tough, right? So let's say you are page number 180, then like, okay, so basically this is the page number 1 and this is page number 300, right? And you have just opened page number 130. That means I mean your destination is in the left side, right? So now you will only search in this range, you will not search in the right side, right? So now you will again open a page uh, from in the middle of 1 to 130, right? So let's say you're opening a page called page number 90, right? So now you know that, okay, the page number 100 will be in this range only, right? Okay, then you can again open some page like, let's say, 96 or something, and then you can iterate to page number 100, let's say, by turning the pages one by one. That's the one thing. So basically, I mean, this is how binary search works, right? We simply look for a middle element, and then we search either in the left side or we search in the right side, right? So that's the idea. Like, let's say if you're searching for 15 here, then what we can do is we can simply find the middle element, right? Like, for this example, okay, let's say we have one more element called 30. So for this example, the middle element is 10. Okay, and this middle element is less than our x. So now what does that mean? That means the x must be in this range, in the right side of this middle index, right? So initially, let's say okay, so let's say, I mean, initially your low index is at 2, which is 0, and right index is, let's say, it's 6, right? So we are simply finding middle as L plus R by 2, which is 3, which is third index, right? So we are simply checking the third index. If the value at this middle index, which is third index, is less than x, that means our desired element is in the right side of the array. So now we'll search in this range. This range means now the left will be 4 and right will be 6. Okay. Now again I'll find middle, which is L plus R by 2, which is 4 plus 6 by 2, which is 5. So now I get this element, right? This is the middle. But now this middle is greater than x. That means we have to search in this range only. Okay. Now the range will become L equal to 4 and R equal to 4. I mean, R is nothing but mid minus 1. Okay. In the previous example, we initialize left range with middle plus 1, right? Because middle was 3. So initialize L equal to middle plus 1, because now we have to search in the middle only. Okay. So the idea is we'll simply compare with the middle element. If that x is equal to the middle element, then we are done. Otherwise, we'll go either in the left side or in the right side. So that is the idea of binary search. Okay. Well, so let me simply explain the code of binary search, right, so that you can understand things easily. Let's say we have a function called binary search. Let's say we have an array like this, and then we have n is the size of the array, and x is the element we are looking for. I initialize the left index with 0. I initialize with right index with n minus 1. And while L is less than or equal to R, what I'll do is I'll simply find the middle, which is nothing but L plus R by 2. And I'll simply check if array of middle is equal to X, then I can simply return middle. Or uh, if array of middle is, let's say, less than X, right? In that case, we have to search in the right side. I'll make the left boundary equal to mid plus 1, right? Because now my range is from mid plus 1 to R. Otherwise, if middle element is greater than X, that means X lies in the left side, right? So that means the right boundary, the R will be equal to mid minus 1. And if you are not able to get that element in that range, okay, then we can return minus 1. We will be out of this loop if we could not find that element in this range, right? So this code will help us to search the element in a sorted array using binary search, right? So this is the code of binary search. Let me know if this code is clear. Okay. Yeah, again, increase my speed. That's fine. Yeah. Do you have any doubt in understanding this binary search? Okay, nice. Looks like all of you know this thing. So, okay. So now the binary search will be, I mean, the time complexity will be simply log n, right? O of log n. Why it's log n? Again, space is of 1 because we are not using any extra space. Let's see how it is log n, right? So what we are doing is we are simply uh, like initially we have to search in the range from 0 to n minus 1, right? And then we are finding middle, then we are either going in the left portion or in the right portion, and then similarly we are so every time we are reducing the search space by n by 2. Like initially the search space will be n, then it will become n by 2, then it will become n by 4, right? In worst case, if we have only one element in the array, then the function, I mean the binary search function will be done, right? So the total steps uh, to reach to 1 from n is log n base 2, right? So basically, let's say these are the x number of steps, right? So if 2x is equal to n, because again each time, so basically we are, if you multiply 2x times, let's say if I'm doing 2 cross 2 cross 2, right? So this is how I can go from 1 to n. If I'm doing that thing x times, so I can go to n, right? So 2 to the power x is n, so the x will be equal to, I mean the number of steps is equal to log n base 2, right? That's why the time complexity of binary search is log n. Yeah. Well, so again, how much different is O of n from log n? Like let's say if n is equal to 10 to the power 18, which is somewhat in the range of 10 to the power 64, right? So I mean 2 to the power 64 is in the range of 10 to the power 18, right? So let's say if n equal to 10 to the power 18, right? Uh, so in O of n, the machine will have to execute 10 to the power 18 instructions, right? And what about log n? In case of log n, how much instructions the machine will have to execute? Any guesses? So the log n will be only 64, right? So if you are solving something in O of n time, that will take 10 to the power 18 instructions to complete, right? But if you are solving something in O of log n, it's only 64, right? There is a huge difference between n and log n. It's not same or similar. Like let's say if a machine takes 1 second to execute 10 to the power 8 instructions, right? So in that case, the machine will take 10 to the power 10 seconds to execute something which is working in O of n if the n is 10 to the power 18, right? But the same machine will take, I would say, some nanoseconds to complete 64 instructions, right? So if you're doing something in log n time, something can be done in nanosecond or let's say microsecond. But if you're doing something in O of n, and if n is really high, so your machine can take billions of seconds, right? Which is, I mean, you can imagine, right? It's a billion of seconds. That's why log n is something very, very efficient than O of n. So I hope you got the comparison between uh, n and log n. Someone is asking why 2 to the power 64 is equal to 10 to the power 18. So it's simple mathematics. If you multiply 2 cross 2 cross 2 16 times, you will have a number in the range of this, right? So it's a simple mathematics. You can simply use a calculator to find 2 to the power 64. You will have something in this range. That's why, so it's a simple multiplication. Yeah. So I hope you understood, like, okay, how, I mean, log n is much, much more efficient than O of n. Okay, Ashwarya saying, can you repeat? Okay, what I was saying is, so let's say if n equal to 10 to the power 18, right? So if you're doing something in, and again, 10 to the power 18 is, I mean, 2 to the power 64 is in the range of 10 to the power 18, right? So they are in the same range. They are, you can say they are equal, right? Because the value of this expression is in that range only. Okay. So if you're doing something in O of n, your machine will have to execute 10 to the power 18 instructions, right? And if a machine is taking, let's say, 10 instructions per second, in that case, your machine will take 10 to the power 10 seconds to complete that task in O of n. So basically, 10 to the power 8 instructions in 1 second. So 10 to the power 18 instructions will take 10 to the power 18 by 10 to the power 10. Sorry, 10 to the power 8, right? Which is 10 to the power 10. That's why to execute 10 to the power 18 instructions, your machine can take 10 to the power 10 seconds, right? But if you are doing something in log n means only 64, right? Because if n is this much, then log n is only 64, right? So to execute 64 instructions, your machine will take 64 by 10 to the power 8 seconds, which is some microsecond, right? This is a microsecond. or some nanosecond. So that's the difference. That's why log n is much more efficient than O of n. I hope it's clear. How 2 to the power x is n? Uh, well, if you don't know much about log, then you can read about that, and then this thing can be easier to understand. Yeah. Okay. Any other doubt? Anything that you want to ask? Any other doubt? Okay, Rudraj is asking, which is better, a recursive implementation or this approach? Okay, in recursive, we will have to use some extra space, right? So iterative is better than recursive. Yeah. Iterative is better than recursive, right? Please repeat how login. So Rahul, you can simply watch the video. I mean, it will be there on YouTube, so you can watch that recording again. Like how the cost of binary search is login. Someone is asking how they're in the same range. So it's simple mathematics, right? You can multiply 264 times. Okay, you will get a number in this range, right? Like let's say if you are multiplying 2, let's say 7 times, right? So you will get 128, right? So what I'm saying is 2 to the power 7 is in the range of 10 to the power 2. Yeah. Okay. Or let's say if you are doing something like 2 to the power, let's say 10, it is equal to 2104, right? Which is in the range of 1000, right? So it's a simple multiplication. When we multiply, I mean 2 plus 2 plus 2 64 times, you will get a number in this range. Or let me show you if I can use calculator. Calculator. Can I use the well? Sorry, I can't. Okay, so I mean, you can use some calculator where you can see that power thing. Sorry, yeah, I'm sorry. I should have used this thing. Okay, the one thing that you can do is 64 will be the power, and this number should be. Sorry, I have to write like 2 to the power 64. Yeah, so you can see this is 1.8 plus 19 means it has 19 zeros, right? Okay. So it in the range of 10 to the power 18, I can say. Or you can say it's in the range of 10 to the power 19. Okay. So that's what that's how 10 to the power 64 is in the range of 10 to the power 18. I hope it's clear now. Okay. Animation, I don't have the scientific calci, so yeah. Well, okay. Well, someone saying nice explanation. Okay. Thanks. Yeah. So this is about binary search. Let's solve some questions which are common to the interviews, right? So again, these questions, no one is going to ask questions like what is binary search and in the interviews. They will ask some good questions in the interviews. Okay. So let's solve few of them. The one question is This question was asked in Amazon, right? So a really good question. So question is finding a square root of a number. Square root will be given a uh, number. Let's say the function is square root. This function should return the square root of that given number. Like let's say if n is equal to let's say 25, the output should be 5. If n is 27, the output is still 5. So basically we will only take the integer value. If n is 5, then also the output will be 5. It's 5.8, but we'll take only integer part, right? That's why it's 5. So yeah, so this is the question. You will have to find the square root of a number, and this question has been asked in like Amazon and all. Actually, this is a very common question. So it has been asked in Google as well, right? So it's a very common interview question. No one is going to ask question like what is binary search and can you write the code of binary search, can you write the code of linear search, right? So these are the very basic things. But to solve questions like this, you need to know like what is binary search, right? That's why I talk about that. Okay. Yeah. So can we solve this question? Well, Agnihotri, we can't use a squarity function, right? Why they ask that question? Like Deepak is saying we can do this in constant time. How we can do this in constant time? So how we can find square root of a number? And you can't use the inbuilt function. You will have to write your own function. You can't use the inbuilt function, right? They are not that dumb that okay they will ask such a stupid question to you. Right? So they are smart guys. How log to n will give you the square root of a number? So Riti is saying brute force approach. So what is the brute force approach, Riti? Well, okay, the one simple approach could be we can simply iterate in the array like this. Like I can start from int I equal to 1 to again the square root of the number can be in the range from 1 to n. What I can do is if I cross I is equal to n, I'll return I. This case will be for perfect number like 25. But what if the number is let's say 27, right? In that case, if I is 5, 5 plus 5 will not be 27, right? So in that case, I cross I, let's say I is 6, right? If I cross I is greater than n, in that case we can simply return I minus 1. What I'm saying is, let's say if n is 27 and I equal to 6, right? In that case, 6 cross 6 will be greater than n, right? In that case, we have to return I minus 1. And this is for the perfect number, like n equal to 25. I equal to 5 will be done. This is the brute force approach, which will work on every case. This is the method one. Again, this is not the most optimized way, but yeah, this is the one way of solving this. This is method one. Yeah. What is the time complexity of this code? Any, yeah. Okay. So the time complexity will be how much? Any guesses? It's not O of n. This loop will break when we will be at a square root of n, right? So the cost is not O of n, but it is a square root of n. So it is equal to square root of n. It's because this loop will break when I will be equal to square root of n, right? It's not O of n. It's a square root of n. Yeah. Someone is saying log n. How this is log n? This is the square root of n, right? It's not O of n. It's a square root of n. Okay. Again, the one optimization could be like you can write till this. That is also fine, but again, that will also take O of x square t of n, right? So yeah. So uh, the cost of this function is square root of n. So square root means, let's say if n is again 10 to the power 18, right? So square root of n will be or 9, right? If you are solving in O of square t of n, that can also take 10 seconds, right? So solving in O of square t is good, but it's not, it's not very good as log n, right? So if you can solve this in log n, in that case, what should be simply O of 64, right? Currently it is, let's say, in the order of 10 to the power 9, 19, 10 to the power 9, you can say. If we can solve it in O of log n, uh, it will be much efficient, right? So can we use binary search to find the square root of a number so that we can improve the time complexity from square root of n to log n? Can you do something? Any guesses, like how square root of n? Because this loop will break when the value of I will be equal to square root of n. Yeah. So how it will be square root of n? Any guesses? I'm just waiting for some time. There's no need to create an array, right? So creating array is not required. Yeah. Okay. Okay, let me solve this. So let's say we have to find the square root of, let's say we have n equal to, uh, let's say n equal to 180, right? So the answer should be 13 because 13 cross 13 is 169, right? So the answer should be 13 for 180, right? So currently what we are doing is we are simply iterating. So we know that, okay, the square root of a number will be in the range of 1 to n, right? So we are simply iterating from 1 and we are going till the n. And once we have that value I, which is the square root of n, we are breaking the loop, right? So that is a kind of linear search, right? And that's why that is taking O of root n time. So can we find that number, that I, which is the square root of n, using binary search? Can we do something? Yes, we can do something, right? Because these numbers are sorted in a way. So let's say again, we know, like, okay, the numbers are in the range of 1 to, let's say, 1. Let's take this example. Let's say the n is 180, right? So I'll find middle, which is 90. I'll find 90 cross 90 is, more than 180. So I know, like, okay, the element will be in the left side, right? So I'll find this middle, which is 54. Then again, I find 22. Then again, I'll find uh, 12, right? Okay. And so on, right? Uh, okay, let's say this number is 160 only. I just want to, show you some, or let's say this number is, I would say, 166. So the half will be 78, sorry, 83. Then the half will be 42, sorry, 41. Then the half will be, let's say, 21, right? Then the half will be 11. And then finally we'll get that number 12, right? Okay, so basically we, okay, if I take a very large number, let's say if you take a very large number, let's say 10 to the power 9, right? In that case, I mean, if you are using that approach of routine, let's say this is 10 to the power 8, right? In that case, you will have to iterate from 1 to 10 to the power 4, which is not efficient, right? But if you are using binary search, then you can find that number in log base n, right? Which will be in the range like 32, or I would say 30, or at max 32, right? Yeah. So in 32 iterations, you can find that number if you're using binary search, right? So this is how we can apply binary search to find it, okay, which number is the square root of that n. Is this approach clear? Yeah. See, again, this kind of questions can be asked in face-to-face rounds, right? So if you talk about the interview process, your first round can be online coding round or machine coding round. In that can be conducted on HackerRank. Okay. So in that interview, I mean, there will not be any interviewers. So you will have to simply submit your code. But in face-to-face rounds or in the whiteboard coding rounds, or now it will be virtual, like it can be on Zoom or some other application, it can be on Google Meet. So in that round, they will ask such kind of questions, and you will have to write code, right? You will have to write some code on some shared doc, and you can't use the inbuilt function, right? So of course you can use the inbuilt function in the online coding round, but in the face-to-face rounds, again, the idea is to judge your knowledge of DSA algo. So they will not allow you to use inbuilt function for this question. Again, you can use inbuilt things for other questions, right? That is perfectly fine. You can use STLs, you can use Java collections, you can use any inbuilt function. But for this question, I mean, which is entirely to find the square root of n, you can't use that square root function, right? Okay. Yeah, so this is the approach. I hope you got the approach to find the square root of n. Someone is asking what is the invitation code. Well, what you can do is you can simply go to this course page, right, and you can contact our team to get that. If you have not, if you don't know how to get that code yet. Well, someone is saying explain it again. So what I'm saying is, let's say we have a number like 10 to the power 8, and we have to find the square root, which will be 10 to the power 4. So the one way could be we can start from 1, and then we can iterate till that number 10 to the power 4, right? Which will be our, our answer, right? So this number should be somewhere like here, right? This number should be here. Yeah. So that is the one way. That is similar to linear search, and that is taking a square root of n. Another better approach could be we can simply search that number using binary search, right? Like we can find middle, which is 5 cross 10 to the power 7, and this number is, I mean, the square of this number is much more than this. So we can again search in this range, can find middle, then we can go again in the middle, and so on, right? So this is how we can find that number 10 to the power 4 somehow in less than 32 iterations, because the log of this value is less than 32. Because and why I'm saying so, because 2 to the power 32 is in the range of 10 to the power 9. And how I know this? I know how to calculate things, so I can, like, 2 to the power 32 is in the range of 10 to the power 9, right? It has 10 digits, 3, 3, 3, and 1, right? So it's 10. So that's why it's a range of 10 to the power 9. Yeah? Well, code for this, okay? So the one thing that you can do is you can simply find, okay, you can simply open that link. And I also can write the code, but let's copy the code from there only. Here is the approach we have, binary search, and here is the code, right? So the starting will be like 1 and n will be the element n. Okay. We are finding middle. If middle is the answer, that's fine. If middle close middle is less than x, that means we have to search in the left side. So we'll do this thing. Otherwise, we'll search in the right side. So that's the way of finding the square root of n, right? So yeah, so and you can simply see the code from this link. Yeah. Okay. Well, I can discuss one more problem. I don't think I have that much time to discuss all these things, but let me try. So the question is, yeah, so I'll give these questions as a homework because all these questions have been asked in the interviews. Some of these questions I can discuss in the next lecture, but let me discuss one interesting question. And the question is a game, and the name of the game is Guess the Number. So this question was asked in Google initially. It's a very famous interview question, actually. Simple. But yeah, I mean, this question can be used to, test the basic understanding of binary search, right? Yeah. So the question is, so you will have a game. Okay. The question is, we have a game. Let's say the game is guess the number. So we'll have a number. Let's say k. Let's say k is equal to 20, right? And we have to guess that number. And in this game, the game will show us a number n, and the range of k will be, so the number k which we'll have to guess will be in the range of 1 to n, and the game will show us this number, like, okay, this is the n, like let's say n is 30, right? So that means, okay, we have to guess a number, and we know that, okay, that number k is in between 1 to 30, right? And let's say we have to enter any number in this box and enter, and play the game. Let's say if you're entering a number called, let's say, 10. So this 10 is less than that k which we have to guess. In that case, the game will print that, okay, you have inserted or you have entered a number which is, which is smaller than this number, right? So the machine, so the game will display a string called smaller because we have entered a number smaller than that, right? Let's say if you're entering 25, which is greater than k, then game will print greater because we have entered a greater number than k. And if you are entering 20, then we are done with the game, right? So basically, we have to find or we have to guess that number with minimum number of attempts. Okay. So how we should play this game so that we can guess that number with minimum number of attempts. One attempt means entering one number is one attempt. Well, okay, then how we can do the game? Yeah, so we have to find. I mean, how we can play this game so that we can reduce the number of attempts, right? So it's very simple, right? We can simply find a middle. Like let's say if we are given case and then let's say we have a is equal to 1 and r equal to, let's say that n. We can simply find the middle. Like in this case, the middle will be 15. We can enter 15 and we'll get. So if we're getting a smaller from the game, in that case we'll search from 16 to 30, right? Then we'll again find the middle, which will be 18, right? Which is again is smaller. So we'll again search from 19 to 30. Then we'll have something like 24, which is greater than 2020. So yes, this is how we can play the game, right? So basically we'll enter by finding the middle of the range, and initially the range will be 1 to n. Okay, and depending on the output from game, whether it's smaller or greater, we can decide like, okay, what should be the next range. So that's the idea. We can simply apply the binary search to do that, right? And the number of attempts will be simply log n. So if this is the n, then in log n attempts we can guess that number. Again, the one case could be, let's say if this number is 20, then the one way could be like we can start guessing from 1 till n. Like we can enter 1, then we can enter 2, then 3, then 4, then so on, right? In that case, that, like let's say if this is equal to 29, right? In that case, it will take 29 attempts to guess that number. So if we are doing things linearly, if you are doing linear search, if you are guessing that number one by one, that will give a solution, but that will take big of n times. So that is not the efficient way. So using binary search can help us to guess that number in log n time. So I hope it is clear. Well, okay, so I have one more question to discuss on, which is based on binary search itself. And the question is, we have to count the frequency of a number in a sorted array. In a sorted array. Like let's say if we have something like, and again that array can have duplicate elements. Like let's say 2, 3, then 3, then 3, then 3, then 9, then 15, right? So let's say if you are given x equal to 3, so we have to find the frequency of 3, which is 4, right? So we will be given a sorted array and we have to find the frequency of a given number. Like if in this array, if we are given 3, then the frequency of 3 will be 4. Again, this question is also very important for the interviews. I mean, this has been asked multiple times. So how we can find this number? I mean, how we can find the frequency of a number in a sorted array? Any guesses? Yes, I'll be sharing my doc. Don't worry, I'll be sharing my the class notes with you, and in that link I'll share all the links of the questions so that you can see the complete working code. Yeah. Well, so the one simple way could be we can simply start, like we can iterate from the, like we can iterate from the beginning, and when we find the first occurrence we can simply, let's say we have a variable called count which will be 0. We'll start from beginning and we'll increment the count if a given, I mean, if that value in the array is equal to that given x, right? Okay. So that approach can take of n time because we are iterating from the array from beginning to the end, right? So because let's say if you have something like this, if you have all the elements in the array are only 333, in that case, I mean, we are iterating from first to last index, right? So this approach can take O of n time. But with the help of binary search, we can find the frequency of an element in O of log n time. And as you know, log n is much, much better than O of n, right? So the idea is if we can find the first occurrence of 3, like at which index 3 is occurring for the first time, and what is the last index, what is the last occurrence of 3. Like the first occurrence is like the first occurrence, let's say first occurrence is f is equal to 2 because this is the index of first occurrence of 3, and the last occurrence is right, like last occurrence is 5, right? So the frequency of, I mean the count of, or I would say frequency of that element will be last occurrence minus first occurrence plus 1, which is 5 minus 2 plus 1, which is 4. So we have, I mean, the frequency of 3 is 4. And we can find the first occurrence and last occurrence in log n time using binary search. So that's the trick. Okay. We don't have that much time today to discuss this question. So what we can do is you can try to solve that problem by yourself and then we can discuss that problem in the next lecture because we don't have enough time, uh, to talk about like how we can find the first occurrence in the array. And also from the next week, I'll increase my speed so that we can cover more and more questions. Because the idea of this course is, to help you to be a good coder, right? Okay. And also, by tomorrow, you will have the access of this doc so that you can try those questions by yourself, right? So now I'll be taking some doubts, or I'll be simply LinkedIn. So you can let me know if you have any doubt to ask. Yeah. Okay, I'm done with the today's question. So now I can take some question from the chat, right? If you have anything to ask, you can ask. Again, the question can be regarding placement, it can be regarding internship, it can be regarding off-campus placement, right? See, I mean, when I was part of Adobe, I had taken some interviews of freshers, and I know like where they struggle to write a code, right? So I've seen many freshers and they struggle while writing code, right? So you should know, I mean, how to uh, solve a problem, and then how to convert that logic to code, right? So you can learn all these things with a lot of practice, and that's why we have this free course for you, so that you can have the basic understanding of all these topics, and you can practice a lot of questions on all these topics, right? So वैष्णव is asking repeat कर दो ये last question please. Okay, last question ये था कि we have to find the frequency of a number in a sorted array, right? Like if we have something like this, like in this array, if we are given 3, so the frequency of 3 is 4, right? Because it is occurring 4 times in the array. So how we can find the frequency of an element in the sorted array in log n time? Because in O of time we can easily find, right? We can simply iterate in the array and we can count the frequency of that number. But we have to solve in log n time. And that can be done using binary search. So the idea was we can find the first occurrence and we can find the last occurrence. So if we have the first and last occurrence, we can easily count the frequency. Yeah. You can let me know if you have any other thing to ask. Sorry, I was not sharing my screen, so sorry. Well, the question is which DS you like to ask in the interviews? I mean, all the DS is important, right? You can't ignore any DS. So arrays, strings, linked lists, stack queue, trees, hashing, graph, try, heap, all these things are important. So you can't ignore any topic. Well, I'll share that question in the doc so you can so you will have that the link of that doc by tomorrow. So don't worry. We'll share that thing on an email. Yeah. Okay. Well, the question from Utkarsh is 55 is a big number. What if we miss few numbers? We'll get the certificate. See, Utkarsh, the idea is if you solve more questions, then only you can be a good coder, right? So the idea is, I mean, the certificate will motivate you to solve more questions, right? And to get that number, I think if you are able to solve 50% of questions, then I guess you can have that number, right? So I mean, you should solve those. I mean, those that much questions, right? To be a good coder. Yeah. So that's why we have that threshold or that cutoff. Uh, well, the question is internship is necessary. Uh, Again, internship might help you to get a job easily because you can get the PPO, pre-placement offer, but it's not necessary to get a job, right? So to get a full-time job, internship is not necessary. You can get a full-time job without doing internship. But yes, internship is helpful because you can build something when you are doing some internship. So it's a good to have thing, but it's not compulsory. You enroll. Okay. Okay, so when I was part of Paytm, my dream companies was like Amazon and Adobe and Microsoft, and I was able to crack the interviews of Amazon and Adobe. So, and I joined Adobe. So, and when I was part of Adobe, the role at Geeks for Geeks, I mean, looked very interesting for me. That's why I joined Geeks for Geeks. So, yeah, so I'm chasing my dreams, right? Again, and again, these things change. Like when I was part of Paytm, I was looking for companies like Amazon and Adobe. When I cracked both of them, I was looking for something different. That's why I switched from Adobe to Geeks for Geeks. Yeah. How to develop your communication skills, right? So, well, I mean, for technical roles, you don't need to be really good at communication. So if you can explain your code, that is good enough to get a SD role, right, for a fresher. But if you are, let's say, if you are being had for a manager role or for a senior role, in that case, they can expect some good communication skill. But for freshers, if you know, I mean, if you are able to speak something, if you are able to explain your code, that is fine, right? Well, which language we should use for preparing good job? Any language. My choice will be C++ or Java because they are quite popular, and you can easily find the code in C++ or Java, right? Because let's say if you're writing code in Scala, and let's say if you are stuck, let's say if you're writing code of Dijkastra or some algorithm, so you can't easily find that code in Scala on Google. So if you're coding in C++ or Java, you can easily, you know, you can easily see the code written by the developers. That's why I prefer C++ or Java. But again, you can use Python and JavaScript. Python is also quite popular. But you can't code in C, right? Because in C, we don't have support of STLs or we don't have support of collections. So let's say if you're writing a code of BFS, which in which you will need queue, right? So in C, there's nothing like there's no inbuilt class for queue, right? So you'll have to write code for queue, and that's why it's better to go with a language in which you have some inbuilt things. Anirudh is asking. Sorry, there's one question I missed. The question was, yeah, this question is 6.6 CGPA is bad? Yes, it's bad. I mean, it's not good. It's bad. But yeah, I mean, you can still get a job, right? So, but still, you can get a job, right? I know my friends who wears 5 pointers or 6 pointers, and they got a job. So you can get a job, and in fact, you can get a job in good companies as well. So it's bad, but I mean, still you can get a job, right? So yeah. Okay, we are running out of time, so I'll take one or two few questions from the chat. Uh, okay, so Dikshant is saying, please guide me for MS Broad Computer Science. I have not done MS, so I don't know how to guide you, but yeah, I mean, you can crack the exam, I mean, the entrance exam, and you can, get a good score and you can get admission in a good university and then you can get a job, right? So that's the, I mean, simple path to do MS from abroad and you can get a job there. So some of my friends are doing that and some of my friends have done that. So the one thing that you can do is you can simply contact someone on LinkedIn who has already done that, right? So he or she might help you in a better way. I have not done MS, so I mean, I don't have much idea about like how and how to give you tips for the same, right? Okay, how many questions we need to solve per day for this GFG workshop? It depends like how much bandwidth do we have, right? So let's say if your exams are going on, right? Like I hope this is the like after some weeks you will have your NSM exam. So at that time you can solve like you can ignore these things for that 1 week when your exams are going on because you should focus on your academics as well. And after that, like you will have winter break. In that winter break, you can solve more and more questions, right? So there's no rule, but if you are, so the idea is you will have to solve approx 300 coding questions in these 11 weeks, right? So you can divide that number and you can have an average number, right? Yeah, it's okay. So see, I mean, in a state board, like let's say in Jharkhand board, 61% is a really good mark, right? So I don't know if it's in CBC board, it's bad. But if in a state board like Jharkhand board or in other state boards, I mean, 61% is a really good mark, right? Uh, the bad thing is that the companies they don't differentiate between the state boards and the CBC board or ICC board. That's the bad thing. But this thing is only for your on campus or your first job. For off campus jobs, CGP or your 10 12 percentage will not matter at all. So let's say if you're not able to sit for a company in the for the placement, right? That is fine. So you can get a job in any company from your college, and then you can switch your dream company after 1 year or after 6 months, right? So for off-campus jobs, your CGPO or your pointers or your percentage will not matter, right? Like when I switched from Paytm to Adobe, I didn't mention my 10th or 12th marks on my resume, right? Again, so I'm also from a state board, so I also don't have very good marks in 10th and 12th. So yeah, but these things will not matter after the first job. Yeah. So these things matter only for the on-campus jobs. For off-campus, these things are not important at all. Okay. Yeah. So let me pick the last question. Okay. Well, the question is how to remember previous algo along with learning new one. I would say by practicing a lot of questions, right? So when you practice a lot of questions, you will remember a lot of things, right? So let's say if you're solving 10 questions on binary search, right? So after solving 10 questions on binary search, you can easily master, binary search, right? Because and this is how you can remember things, right? And of course, you can revise things if you have forgotten something, right? So after practicing a lot of questions, I mean, it's not easy to forget things, right? So things will be in your memory if you have done enough questions on a given topic. Well, okay, this is the last question of this session. I'm not from CS or IT branch. Will the interview same? Yes, they don't discriminate on the basis of your branch. So if you are offering you, a job as a SD or software engineer, so irrespective of your branch, they will ask the same question, right? So so you can expect the same questions, right? So again, you'll have to learn the similar things like DSA algo and CS fundamentals like OS, networking, and DBMS. You can ignore other things like compiler design or other subjects, but you can't ignore DSA algo. Okay, thanks. So I'll be live in the next week on Wednesday, and we'll start with string and searching and sorting. We'll cover more questions on searching. Then we'll start sorting, right? And of course, you will have. I mean, all these things. My class notes will be shared with you, and also you can ping me on LinkedIn. I'm there, so you can. If you have any specific doubt, then you can ping me on LinkedIn. Okay. So thank you. Uh, Thank you guys. Bye.